Okay, in this example, we're looking at a bag of marbles, with 11 marbles, 3 that are red and 8 that are blue. But in this case, it's going to be without replacement when we draw 2 marbles. So this will end up affecting the probability of the second marble, because as we take the first marble out, we're not going to put it back. We're going to hold on to it. And so we're going to use a tree diagram to see the consequences of that. So this tree diagram has already been set up in this example. So here at the very top, this is where we have our first draw. And right here in the tree diagram is where we have our second draw. And this is without replacement. So if we look on the left-hand side, and we look that if we had drawn a blue in the first draw, we can see that our sample space is going to be 11. So we have 11 marbles in the bag. We're starting with 8 blue marbles and 3 red marbles. On the right-hand side, it's going to be the same conditions. So we're starting with 11 marbles. We're starting with 8 blue marbles, and we're starting with 3 red marbles. So when it comes to calculating the probability of getting a blue marble on the first draw, it's going to be 8 out of 11, because we've got 8 blue out of 11 total. And then over here for red, it's going to be 3 out of 11, because we've got 3 red marbles in the bag out of a total of 11. Okay, but now we're going to see the effect that without replacement has on the probabilities of the second draw. So let's look at the left-hand side first, which is the first marble being blue. And so if we look at our sample space, we no longer have 11 marbles in the bag, because now the first one, we're holding on to it. So now we've only got 10 to choose from. And on this left-hand side branch, the number of blue marbles we have now is going to be 7, because we chose a blue one and we're holding on to it. So now there's only 7 blue marbles in the bag. And since the first marble was blue, we still have all the red in the bag. So when we look at the probabilities of these 2 branches for the second draw, we can see that we've got the probability of there being a blue marble, given that blue was first. And so we've now got 7 blue marbles out of a total of 10. And here for this branch, the probability of getting a red marble, so the probability of getting a red marble, given that blue came first, it's going to be 3 out of 10, because we've got 3 red out of 10 total possible. Okay, so now let's look at the probabilities on the right side. So on the right-hand side, for the first draw, we got a red marble. So now in the bag for our second draw, we now have 10 marbles in the bag, not 11, because we didn't replace that first marble. And because our first marble was red, we still have all of our blue marbles. But now the number of red marbles that we have in the bag, now that we've decided to keep one, is 2. And now as we start our second draw, and we draw these two branches, we can see this left-hand branch would be the probability of getting blue on the second draw is going to be the probability of getting blue given that R was first. So the probability of getting blue given R came first. And now we've got 8 blue marbles out of a total of 10 in the bag. And for this branch on the right, choosing a second red, so the probability of getting red given that red was chosen first. And now we've got only 2 red left in the bag out of a total of 10. So this is how you work out the conditional probabilities for each of these different branches. So now let's calculate the total probability using the multiplication rule across connecting branches. So the first one, we'll look at the probability of getting 2 blues. So if we look at the probability of getting 2 blues, it'd be blue on the first draw and blue on the second draw. And so the probability of getting blue on the first draw was 8 out of 11. And the probability of getting blue on the second draw was 7 out of 10. And so 8 over 11 times 7 over 10 gives you 28 out of 55. Okay, so next, let's look at the probability of getting blue first and red second. So the probability of getting blue first and red second is going to be the probability of getting blue on the outset. That was 8 out of 11. And then the probability of getting red second, which was 3 out of 10. And so 8 over 11 times 3 over 10 is 12 out of 55. Okay, now let's look at the red side of the branch. So down here at the bottom, we've got the probability of getting red first, followed by blue second. So that's going to be red in the first draw and blue in the second draw. And so the probability of getting red is 3 out of 11. And then the probability of getting blue second is 8 out of 10. 3 over 11 times 8 over 10 will reduce to 12 over 55. And finally, if we look at the probability of getting 2 red marbles, so that's getting red on the first draw and then red on the second draw. So getting red on the first draw is 3 out of 11, and getting red on the second draw is 2 out of 10. 3 over 11 times 2 over 10 reduces to 3 over 55. So let's kind of look at those probabilities down here at the bottom. So the probability of getting 2 red comes out to 5.45%. So notice that this probability of 5.45% of getting 2 reds is less than the probability of getting 2 reds with replacement, which comes out to 7.44%. So the fact that you're taking a marble and holding on to it actually reduces the probability of getting 2 of the same color, of getting 2 reds in this case. And as we look at the other examples, so if we look at getting 1 blue and 1 red, that's actually kind of 2 colors here. So I'll just use green to kind of represent that. So here when we're looking at getting 1 blue and 1 red, so that's either one of these 2 scenarios, then that's going to be 12 over 55 plus 12 over 55, which gives us a probability of 43.64%. And that's versus 39.67% with replacement. And let's look at a third example. So getting red only, or getting red first and then blue second. So let's take a look. That's going to be this color. So if we look at the probability of red first and blue second, that comes out to 21.82%, and compare that to 19.83% with replacement. And finally, if we look at the probability of red given that blue occurs first. So remember, using conditional probability, the probability of red given that blue occurs first means that we're starting here at blue having occurred first. It's a foregone conclusion. So the only probability we're concerned with is this last branch here for red. And so the probability of red given that blue occurs first is 3 out of 10, or 30%. Compare that to the probability of red given blue with replacement is 27.27%.